Hello, everyone. It's my pleasure to be here. My name is Giedrius, and I'm here to present my topic, Logs Go LLD. First of all, very quickly about me. So I often consider myself as the one who loves monitoring, programming, and automation. And if there was a single thing which I don't enjoy, it would be talking too much about myself. So let's proceed to the topic. So logs. Logs are actually all over the places. Logs are being generated by various different systems, processes, applications, web servers, operating system, etc. And what you typically want to do with those logs is you want to monitor them. You want to analyze them. You want to catch some errors, warnings. You want to count something useful there. And Zabbix provides two very useful items for that. It is log and log count. Those are actually perfect items for many use cases because they are efficient performance-wise. They come with the Zabbix agent out of the box, meaning that you don't have to install anything additionally. You just install Zabbix agent and you use them. But are those items enough? That is the question. I would say that for most cases, when you have a limited range of patterns to be defined, when it's kind of simple, and most checks are actually simple in the end, so those items are really enough. But what to do in more complex cases? And I would like to define several of them, so you would understand what is more complex. First of all, what to do when you have multi-line analysis needed. Log is designed so that it works in a single line level, meaning that you analyze line by line, and you cannot really extract some information if you need to analyze multiple lines. For example, if you have a request-response type of thing, when requests come in one line and responses come after some time as another line. And they might be joined by some unique identifier, and you would like to know, for example, whether a specific request received a response. So this is kind of not possible with a log item. And for that, you would need some custom approach. Another use case which I consider as kind of complex is cases when you have to define a huge set of patterns. Imagine something like HTTP status codes. What if you would like to monitor counts for them during the time? You should then set up tens, I don't know how many different HTTP status codes we have, something like 60 something maybe. So you would have to define them one by one. Of course, you could clone them. At the best choice, you might create one item, then export a template, and then somehow with a script or manually copy-paste the item and have all the set working. But this is kind of painful, I would say, and this looks immediately like an object for LLD. So that is exactly my solution. And I will now present it. So first of all, about the concept itself, how it works. I was trying in the first place to keep it as simple as possible. And this means that the approach is implemented in a bash script and used as a user parameter. This is nice because it is kind of portable. You can move this script all around the Linux. It is not needed to be compiled since it's a bash script. So it doesn't have any sort of dependencies, so you just add the script, add user parameter, and it should work. Next thing, this idea, it relies on regular expressions. So whether you monitor something with the Zabbix agent with the log items or you use this LLD, you should be familiar with regular expressions, what they are, how to use them. And to be more precise, it is actually based on capturing groups. This is a very, very powerful feature of regular expressions. It allows you to extract portions of your data which is being matched and later on use it. Last thing here is that I chose to use Perl type of regular expressions. And this is actually for two reasons. First of all, I find Perl type of regular expressions most powerful ones. And those who deal with text analysis more, you would most likely agree that once you want to find something very trivial, you would most likely do grep something. Once you have something more complex to catch, you would like to use grep minus capital E, which stands for POSIX extended. But when is that not enough, then you will most likely use grep minus capital P or pgrep, which stands for Perl type of regular expressions. And another reason why Perl is because Zabbix itself, I think since version 4, they started using Perl type of regular expressions. So then the discovery regular expression and item prototype regular expression, they might be shared with no trouble. Another thing about this approach is that low-level discovery is not data collection. So once you collect some data from logs, you would typically want to do it very frequently when talking about log item. You would run it each second, each 3 seconds, each 5 seconds, but really in high frequency. With low-level discovery, it's a bit different. You don't want to run it as frequently as data collection because you discover something and you want to collect the data later on. So you don't have this need to run it frequently. And that might become a problem if you have a huge log files, because if you run your discovery something like once an hour, once per half an hour, even once per 10 minutes, and if you have a huge amounts of data, and you would like to keep the same fashion of this low-level discovery as you use in data collection, means that in data collection you scan your log portion by portion. So you read something, and then after some time you run it again, and you read just the portion which was created during 2 runs. So if you would keep the same approach here with the low-level discovery, you might be in big trouble if you have huge logs, because it would become really slow. And that's why I implemented this approach with possibility for you to choose how many lines you would like to analyze. It means that once you run this discovery, it takes last given amount of lines and tries to find something there. So it's all about knowing your environment, knowing your logs. You should know how frequently a specific log is being updated, and by that choose this number of lines to be analyzed in each run as per your needs. Also, the frequency itself of low-level discovery is nothing new. You also choose it freely as per your needs. Now about keeping it simple. So this is how it looks like from a configuration perspective. It's really kind of simple. It's a script which you run. You provide 4 parameters for it, which are kind of self-explanatory from the variable names. So first one is a log file you want to tail. Next is number of lines you will analyze. Entity key is just a naming for the discovery JSON. And the most important one is the pattern itself. One thing to mention here, which stands out a bit, is using unsafe user parameters. They must be enabled. And that is because if you don't enable them, you will most likely face a situation like this. Since regular expressions, they tend to have all the characters which are listed as unsafe from the Zabbix agent. For example, character classes, square brackets, and yeah, asterisks, and so on. So you should enable this parameter. Now, once again about keeping it simple. So a script itself is something like 70 lines, but the whole essence of this discovery is actually in those 3 lines. To be more precise, it's actually in this pipe here. I will explain each of the sections a bit later. But just to show you how simple the discovery is, it is actually here. Let's take an example, and you will maybe better understand how it works. So imagine that you would like to count all the HTTP status codes that appear in your web server log. So the Apache config looks like that, and you would like to catch this highlighted part, and later on count it. So this is the real line example. And what we actually do is we provide for the script those 4 parameters which I mentioned. So the log, number of lines to analyze, name of the entities in your discovery JSON, and regular expression itself. So important thing here to notice is the capturing group, which is 3 digits here, which represent the HTTP status codes. And once you run it, you get the set of data which you wanted to have. From Zabbix GUI configuration perspective, it looks like that. Again, nothing too complex. Same as from command line, so all those 4 parameters. And then, as I mentioned, discovery regular expression might be shared with the item prototype regular expression. Just what was before the capturing group now becomes the LLD macro. And this is the result. So you discovered multiple HTTP status codes there in your log, and you created 5 items, which counts later on number of matching lines per minute. Let's take more complex example. So the example itself will be more complex in a way that it will have not a single capturing group, but 3 capturing groups, because in this example, you want to analyze the durations of the requests, but now this time grouped not only by HTTP status code, but by HTTP method as well, by HTTP status code, and by specific domain. So again, highlighted parts. What you do is actually nothing much more complex here. You provide 3 capturing groups instead of 1, and that's how script automatically uses all those 3 capturing groups, and it will provide you sets of data which are actually what you wanted to see. So HTTP method, HTTP status code, and specific domains. Configuration, nothing too complex, nothing too different from first example. All those parameters, just what you have to remember is that capturing groups are your best friends, yes? So as many of capturing groups as you will have, as many of components in the JSON you will also have. Since in Apache config, I had durations of those requests defined in microseconds, here's a good part to introduce or remind that you should use pre-processing in case you have such a need as I have now. And pre-processing can be applied both to discovery itself and for item prototypes. As well as pre-processing, you should also consider using filters. If you cannot construct your regular expression so that it would already discover what you need, you might want to apply some filtering. So in this case, for example, I decided to have not all of the HTTP methods, but just get and post. So I would like to get rid of heads and options and whatnot. I just want get and post. So this is just a reminder that you should use Zabbix native features, such as pre-processing, filtering. Don't forget it, it will make your life easier. And again, this is the result. So you have durations being monitored, automatically created with a HTTP method, HTTP status code, and specific domain. One thing worth to mention as well is naming of your item prototypes, and later on what becomes items. So if you wisely select names for the item prototypes, you will then be able to use wildcards here in the dashboard widgets nicely. And for example, in this case, since I have here I would have HTTP method, and here I have HTTP status code. So I can divide them into 4 subcategories, so 200s, 300s, 400s, and 500s. And that is how something new appearing in your log might automatically also appear thanks to wildcards, very nice feature. It will automatically also appear in your dashboard widgets. So it's kind of full automation. So I promised to explain the pipe logic. So let's quickly do it here. So first of all, what this discovery does, it tails your log with a number of lines that you provided for the script. This is what I talked before. Next step, you immediately try to grab the provided pattern out of the log. In case of simple patterns, say one capturing group or something quite simple, it will already make it really fast for the further steps. So it is to make things easier. Next step is actually most important one. Here I invoke a Perl snippet, which prints out the output of all of your capturing groups, separated by space in this case. So this is, if we would talk that this whole pipe is the essence of discovery, then this part is the essence of the pipe. It's the most important part here. The last step is sorting the data by uniqueness, because this is a criteria for discovery. Discovery would work even if you have some duplicated entries, but it would provide some error in the discovery GUI. So in order to avoid that, you already provide unique records in your sets of data. So this is how it looks like as a whole line, and highlighted parts are exactly an object what happens after this pipe runs it. Now, the purpose, of course, of this pipe is to do its thing. It's to collect the data which you need, but also another purpose is to do it fast. So who wants to build slow things? We want to build fast things. And even if it's not so important as in data collection, discovery is also, at least in my opinion, should be fast as it can be. So I experimented a lot actually, and this whole pipe actually ensures the speed. And now I will show you what I mean by the speed. So imagine that for the sake of demonstration, I specifically created such a regular expression, which is not efficient. It includes seconds from the timestamps. It includes also what is in between the user agent, and it also includes the request durations, which could be outside the regular expression, but I intentionally left it here to demonstrate the speed. So what this means is that we have a lot of unique lines after grep part. That is exactly because of what I explained. So I'm leaving seconds, I'm leaving durations, I'm leaving user agent. So it makes all the lines having something highly different, and that's why you have a huge set of data before you invoke the Perl, which prints the output of caption groups. So I have 44,000 lines there, but once you run the script, you will see that out of those 44,000 lines, you will have 68 different sets of data. And the thing is that this whole analysis is being performed in less than a second. So if I would choose my regular expression to be better, it would run even faster, but even with this regular expression, which intentionally has too much unnecessary parts, it runs in less than a second. For such amount of data and for a purpose of discovery, I am really happy about this result, and I consider this as at least fast enough for the discovery. So this whole script, this whole thing, I like to consider it as a working thing, so you can take it and use it. But I also like to think about it as an abstract idea, how to do things. So that's why it is easy to change something, modify it, because you might have some different needs than to discover things in a way that I presented. And here's the example what I mean. So imagine that you would like not to discover each and every entity which is in your log, but for example, for some reason, group one of the caption groups or two of the caption groups into some subcategories again. So for example, in my previous example, I had HTTP method, HTTP status code, and specific domain. But what if I would like to group HTTP status codes into two subcategories, something like 200s and non-200s? How to do it? With that initial discovery script, it would be impossible because it literally discovers each and every different HTTP status code. So what to do? I modified the script, and there is another version of it. I will provide those both scripts in GitHub. So this additional modified script, it accepts a fifth parameter. It is as many as caption groups as you have. Here, for this fifth parameter, you should provide as many alternatives for each of the caption groups separated by a semicolon. So here, for example, with the first caption group, I don't do anything. With the second group, I group it by 200s and non-200s. And then with third caption group, I also don't do anything. So it will be literally as is in the logs. And this is how it looks like once you run it. So you get all the HTTP methods, specific domains, but this time, HTTP status codes will be grouped into 200s and non-200s. It is just an example how can you transform or modify the script if you need it. And this is the result again. So HTTP method, 200s, HTTP method, non-200s for specific domain. And yeah, both of the scripts as well as user parameter file are provided here in my GitHub. Feel free to download it, feel free to use it, feel free to modify it. Feel free to catch me and discuss if you like here in Summit, or contact via LinkedIn or somewhere else. And Yeah, that's it. Thanks.
We have a couple of questions for you after seeing this very cool method, I must say. And one of the questions would be, were there any unexpected surprises with the keep lost resources period, and what exactly was the period in the end?
So the question is, was there any unexpected results with the keep lost
Resources period, like some status is suddenly gone, undiscovered.
Yeah. So I think, again, as I mentioned, the frequency of running the discovery and the amount of data you analyze for discovery highly depends on your use cases, on your logs. So the same is applicable for a retention period, like how long you will store your discovered stuff. It highly depends on you. If you need to actually store it for longer time, you store it for longer time. Or, for example, if your discovered entities are not so highly repetitive, it means that you, for example, some HTTP status code, weird one, I'm a teapot 418, if you don't return it frequently enough, it will, of course, in logs, it will also be very not so frequently appearing. So that's why you once might discover it, and you would like to collect it, but during next discovery run, it will not be there. So, of course, you should consider all those things and set this keeping lost discovered entity as per your needs. Mm-hmm.
And just one more. So how did you end up closing the problems? Manually or maybe correlation?
How did I end up closing problems? Is it related to this presentation? Because here I didn't even talk about triggers or problems.
That's why I assumed the question was there. So if you detect the statuses, you probably detect
Although to answer questions directly, yes, I understand how to close the problems with a correlation, and we heavily do it once we have a need to avoid the flood of repetitive events. So we sometimes consider that, and in our environment we use this feature. Yeah.
Thank you. Thank you for the answers and your time.
Thank you.